So, dear participants, thank you very much for joining the session once again. Welcome back. Today's just wait for 2 minutes, then will be started the session. Let's wait for some other participants. Once other participants join it, then our next speaker, Mr. Deepak Upadhyay, he will demonstrate in today's session. So you can ask your queries, whatever your queries will be there, that you can ask to our next speaker. So let it wait for 2 minutes, participant, please. So in this first session, basically our speaker will cover about the demonstrations on the device level, even some material questions you can also ask to him as well. And device simulation will be covered mostly today. Okay, so first session you have no need to do the hands-on. Hands-on will be given in second session after 2 p.m. Okay, first session just try to understand how the speaker are doing the device modeling simulation in this NanoDCAL device studio software. So that try to learn in the first session, and second session you can implement it. Okay. So let's we would like to invite our second speaker, Mr. Deepak Upadhyay. He will demonstrate in this session and how this NanoDCAL can be more effectively utilized by you, and you can become a familiar in this material level simulation, device level simulations, and even after today, whatever your queries will be there, that will be also helped by me as well as my colleague Deepak. So he will demonstrate to you. Once again, I would like to invite him to give his live session on this device modeling simulation. Second session, you can try for hands-ons. So thank you, Deepak. You can kindly share your screen and provide that your knowledge to our.
So this is my device studio that I would like to open. So I would like to start from the scratch. So I will click create a new project and then enter my name of the project. And then I click on the save option. So this is my device studio, that is basically a user interface for this NanoDCAL and NanoDCAL software, and that will help you to do some modification, manipulation in your atomic structure, crystal structure and device structure as well. So first of all, I would like to give you some brief idea whatever you have. So is in study in session. So this is file option. In file option you can see this is for creating the new project. You can open your existing project that you are working and you can save your project, and this is for creating the device structure, crystal structure, molecule structure, and this is the import option. So this software have two options to import the material. Either you can import the material from local database that exists inside this software, either you can import the material from the online database. So this is the import local option. And you need to relocate your project software. Here you can see this is the material that exists inside this software, like 0D material, 1D material, 2D material, 3D material, and some organic material is there. In 0D material you can see some molecule, amorphous and crystalline is there. And this is 1D material, some nanotubes in different combination of 12 vector and NEM value. And this is 2D material, some novelty material, arsenic, bismuth, black phosphorus, and this is the graphene. This is 3D material, some conductor, insulator, layer material, metal oxide, novelty material, semiconductor is there. In conductor you can see some pure metals, and this is the pure metals. This is the insulator. This is the layer material. This is metal oxide. This is novelty material, some perovskite, topological insulator. This is perovskite, topological insulator, and this is semiconductor. So the conclusion is all about that. This is material database that exists inside this software. So if we talk about the creating the new project like device structure, crystal structure, molecule structure. So this is the crystal builder where you can see some space group, various space group are there. 1p1, 1p2, 2p2, 3p2. So according to your space group, you can select and then previous lattice will automatically selected. And you can also change your ABC value, alpha beta gamma value, and also you can include the atoms like this is the default carbon atom is selected, and if you want to change then you can single click and then periodic table will open, and from periodic table you can see you can select any atoms whatever you want, and you can select and you can click on the OK option, and you can see primitive preview style, primitive cells, conventional cells, equivalent atoms, and whatever crystal you want to create. So you can put your space group, define your element, and you can click on the preview option. Then you will able to do some crystal structure. And if you want to create some molecule structure, so you can go into the new option and you can click on the molecule. Here you can see this is the molecular builder. You can select any atoms from the periodic tables, and also you can change their fractional coordinate point, and you can click on the preview option and you can build. If we talk about the build option, in the builder you can see some device structure like left right, left center right, bottom top, bottom center top, front back, front center back. So this 6 type of structure you can create. And you can see this is the interface builder, field junction with atoms, cat2 atomic. This is the crystal builder. You can also redefine your crystal, surface slab, symmetry, standardized cell, molecular structure, decomposition, graphene nano ribbons, nanotubes, grain boundary, nanotubes, nanowire, disorder graphene like structure, disorder zinc blend like structure, icosahedron, cubectohedron, wolfish cluster, bond option, and this is for converting the file. If you talk about this device simulation, so for the device simulation, first you need to import some material for the electrode, like left electrode, right electrode, front electrode, top electrode, bottom electrode. So I would like to click on file option and import from the local database. This is the material. I click on the 3D material and I want to import some conductor. Here you can see this is some pure metals. So I want to import some gold atom. So I have selected this gold and click on the open. Here you can see the gold atom has been imported from my local database. And if you want to show the FCC, BCC of this gold atom, so you can click on the build option and go to the redefine crystal. Here you can see this is for face center cubic structure, body center cubic structure. You can click on the face center, and here you can see this is the face center cubic structure of this gold atoms. And if you want to see the body center cubic structure, this is body center, and you can click on the preview option. This is the body center cubic structure. So I want to show face center cubic structure. This is face center, and click on the preview option and then click on the build option. And if you want to make a supercell of this gold atom, like if you want to some redefine in C direction, A direction, B direction, so you can click on the build option, and in the builder you can see this is redefined crystal. And here you can see this is A, B and C. So where you want to make a supercell, you can select You can see this is the 224, and I would like to click on the preview option, and this is the supercell of this gold atoms. So you can see in a very quick time you can make a supercell, and you can click on the build option. This is the 3D viewer where you can see like XY view, XZ view, YZ view, YX view, ZX view. So this is the XY view, and this is the XZ, this is the YZ, this is the YX, and this is the ZX. And if you want to release some undesired atoms, suppose if you want to release this all atoms, so you can select and you can click on the delete atom. So you can select any atoms and you can click on the delete option. And this is the XY view, and if you want to show the ZX view, so this is the ZX view, and you can rotate your structure like that. And if you want to release some more atoms, so you can select the atoms. I would like to deselect these atoms and click on the delete atom.
One question, to deselect a particular atom, only left click.
And suppose if you want to make increase the vacuum inside this unit cell, so you can click on the convert to crystal option, and here you can select the vacuum like in the direction of A, direction of B, direction of C. So 20 times in the direction of A, 20 times in the direction of B. You can see the vacuum has been created inside this unit cell, and you can click on the build option. And if you want to make it centrally fit, so you can click on the center option, and in the center option you can see this is the center along A, center along B, and center along C. So this is the center along A, and this is the center along B. And if you want to create a mirror of this unit cell, so you can select all these atoms and go to the mirror option. This is the mirror atom, and here you need to define the normal vector XYZ. You can see this is the XY, XZ, YZ, and also you can define the distance. And then you can copy this checkbox and click on apply. One second. Here you can define the distance. I have taken more distance. And then you can copy this checkbox and click on apply. You can see the mirror has been created. And if you want to show this both electron in between the unit cell, Then you can click on the convert to crystal option, and here you need to define the vacuum in the direction of C, so that both the electrode in between the unit cell. You can see both the electrode in between the unit cell, and then you can click on the build option. And if you want to add some molecule structure inside this in the center position, so either you can create the molecular structure through this, or either you can import the molecule from the local database. Here I have created some benzene molecule. So here you can see this is the benzene molecule. So either you can import the material molecular structure, or either you can create the molecular structure through this molecular builder. And then you can copy this molecular structure, Control C, and then Control V inside this unit cell. If you want to make it centrally fit, so you can select all these molecules and you can go into the center position. Also you can rotate your molecular structure, so you can select all this molecule and then go to the rotation. Here you can see this is the rotation along screen vector, x, y, z axis, ABC vectors. So you can select any, like a screen vector x, y, z. So I have selected this screen vector, and here you can also define the angle. And here you can see this is the counterclockwise x-axis, and this is the clockwise x-axis, and this is the counterclockwise y-axis, and this is the clockwise y-axis, and this is the clockwise z-axis, and this is the counterclockwise z-axis. So whatever position you want to make a rotation, so you can select, and also you can define the angle. And if you want to make more rotation, like 45 degree in the direction of Z, and if you want to add some molecule atoms in between these two atoms, so you can select these two atoms and go to the add a new atoms. Again you can select these two atoms and go to add a new atom. Here you can see the default gold atom has been selected. Here you can see this is the property window where the property of our whole structure, this is the whole structure, property of whole structure, total number of atoms. And if you want to show the property of individual, so you can select, this is the gold atoms and this is the XYZ position. And if you want to change this gold from another atom, so you can select and you can go into the replace atoms. Here you can select any atoms, like suppose if you want to make sulfur, and then you can click on the OK. You can see the sulfur has been replaced, and similarly you can select this one, this atoms, and here you can select this sulfur.
Sir, how to connect these to electrode tips?
Yes ma'am, can you repeat?
Yes, ma'am. Sorry.
How to connect these atoms to the electrode tips, that is left side
Okay.
and right side electrode, to make a device.
Okay, Manoj. So I can show you. I can show you. And suppose if you want to move this electrode, so you can select this electrode and click on the
Company
move option.
company na kaluya. Hello.
Here you can select whatever position you want to move,
Abhi
like
nakasuh bhai.
along x, y, z, unit cell
Abhi
vector,
nakasuh
screen view,
Hmm.
and also you can define the
लाल तो
distance.
पहले है। हम्म। 1-2 महीना बाद तो कर सकता हूँ, 2 महीना बाद तो 1-2 महीना बाद
Also you
चाहिए
can
तो
do
बोल
this
कर देंगे
move these items.
वो डाल ले तो कर देंगे बाद में। ठीक है, पेमेंट आनी आई ना आनी है वही पेमेंट, 2 पेमेंट बची हैं 10 लाख की।
And if you want to move this one,
के भाई 2 पेमेंट बची हैं, 2 महीना तो 2 पेमेंट रुकी हैं और जनवरी में आ गया, नई साल हुआ तो लेट हो गई।
and to make a connection between these three and these three, you can click on the recalculate linker one. Just 1 second. So you can move any atoms like that. And to make a connection between these three and these three, you can click on the recalculate linker one. You can see all the atoms and is connected with by the covalent bond.
गाँवली सफाई तो वही तो बना रही।
And to make a device structure, so you can click on the convert to device option, and here you can define the electrode like left electrode, right electrode, bottom electrode, top electrode, front electrode, back electrode. So in this device structure there is 2 electrode, this is the left one and this is the right one. So you can select left electrode, right electrode, and also you can define your electrode value, like if you want to change this one from another, like -6, and then you can click on the preview option. Here you can see this is the left electrode and this is the right electrode. So you can create either 2 probe device structure, 3 probe device structure, so up to 6 probe device structure you can simulate from this software. And if you want to calculate this device property, so you can click on the simulator, and in simulator you can see multiple options are there. NanoDCAL, this is for DFT and NEGF method, and this is the RUSCHEM for DFT and DFPT, density function perturbation theory. And this software also support the user interfaces WASP, LAMPS, OVITO, Quantum Expresso, Gaussian, Newton. So you can click on this NanoDCAL, and this is the SCF calculation, self-consistent field calculation. So here you can define whatever parameter you want to define, like electron temperature, cutoff energy, exchange correlation function, LDA, GGA, meta GGA, and also you can change the K point sampling. This is the contour integral lower bound, circle point, and this is the electrode. This is the left electrode and this is the right electrode. This is for the left one and this is for the right electrode. Electron temperature, electrode voltage, K point, and this is the iteration control, like density matrix, Hamilton matrix, total energy you can also include. Suppose if you want to include some total energy, so you can select this checkbox, and whatever parameter you want to include in total energy you can. You can select like that. And also you can change the maximum step, mix method, mix rate, mixing variable, Hamilton matrix, density matrix, real space density. And this is the basic settings like arrangement by element, by atoms, and this is the Howard atoms. Some SPDF combination is there. And also you can include your doping. Suppose if you want to include some doping, so you can select this checkbox, and here you can define the doping. Like if you want to do doping, so you can click on the plus icon, and whatever parameter you want, like whatever element, so you can select and you can define. And this is the spin type. Suppose if you want to include some spin tonics application like collinear spin, general spin, so you can include. This is the collinear spin, and this is the atom. And suppose if you want to make general spin, this is the general spin, and this is the spin orbital interaction. And then you can click on the generate file. So you can send the parameter as per your requirement, and then you can click on the generate file. Once you can click on the generate file, in the project window you can see the SCF input for device part, and this is the SCF input for the left electrode, and this is the SCF input for right electrode. And if you want to show the script of this device, so you can right click and click on the open with. Here you can see whatever parameter I have defined, and this is the basic settings. I have selected 100 Kelvin in temperature and 80 Hz cutoff energy, and this is the exchange correlation function LDA, and this is the space grid number, and this is the description of electrode. You can see there are two electrode is there, left and right, and this is the contour integral. I have selected no spin, and this is the iteration control. And this is the total number of atoms and their Cartesian coordinate point. So this script will automatically generated once you click on this generate file. And this is the script for the left electrode. In the left electrode you can see total number of atom is 14, and this is the right electrode. And if you want to calculate some properties analysis part, so you can go into the simulator, go into the NanoDCAL, and then you can select the analysis. This is the device property like density of state, effective potential, total energy, scattering state, transmission, photocurrent, IV curve, charge, electron density, potential, conductance, thermoelectric current, Seebeck coefficient. So whatever property from this structure you want to simulate, you can select, and then you can click on the generate file. Here you can also select this is for the device part, and if you want to analysis for the left electrode, right electrode, so you can select this is the left electrode, and this is for the right electrode. And then you can select like this is the density of state, number of energy point, energy range, and this is the projected. Like you can also select atom orbital, and this is the K-point sampling. This is the effective potential. Here this is the this is the total energy, scattering state, this is the transmission, photocurrent. You can see this is the for the photocurrent calculation. You can also define the polarization basis, E1 and E2, polarization vector, linear polarization, elliptical polarization, circular polarization. So whatever polarization you want to include, you can select. And this is the theta, phi, minimum and maximum value is also defined. You can define. And this is the photon energy range, minimum and maximum. And also you can define the K point sampling for this photocurrent calculation. And also you can irradiate your atoms. Suppose if you want to follow the
Sir,
light, yes,
this is the left electrode, right? Not the left interface.
yes.
If you want to analyze the left interface between the central region and the left electrode, what should we do? This is just like just the left electrode and the right electrode. What about the central region?
So you can select like this is the device and this is the left electrode. This is the for the left electrode property.
This is not the interface, right? Just only the electrode material.
So first you need to create an interface, like this is the device structure. And if you want to make an interface, then you can go into the build option and here you can select this is the interface builder. And here you can select the electrode, like any electrode you can, like this is the gold.
For the analysis part of this interface, what should we do?
Ma'am,
This
I can,
selecting just the electrode, right? Not the
yes.
interface.
Okay, ma'am, I can show you.
Okay.
Like if you want to make an interface, this is the gold one. And if you want to make an interface between gold and silver, so first you need to import this silver atoms. This is the silver. And then you can go into the build option and here you can click on the,
Separately study the interface, right? In this device section, can we separate this like left interface, right interface? It needs separate calculation.
for the electrode and left one and right one and center part.
Okay. But left one plus the central part, can we do the analysis?
Yes, ma'am. Like you can see, and this is the script for the left one. Once you click on the run option,
Okay, this left electrode means left electrode plus the central part.
here you can see in device part you can see this output will take from the left electrode. Here you can see it will take from the left electrode. Either you can select from the right electrode. In this device structure you can see both the electrode is equal and same, like you can say. So no need to run this left one and right one. So you can select this left one. And you can click on save. Then it will take the output from the left one and this is for the center part, left one and center part. Then you can click on the simulator, go NanoDCAL, and here you can analysis.
Okay.
So this
Thank you.
calculation is for the left one and center part.
Okay, okay. Now I
And you can select this is the density of state, effective potential, scattering state, transmission, and this is the photocurrent. Also you can irradiate your atoms. Suppose if you want to fall the light on the center part, so you can select this center region and here you can click on the select. This is the combination of center point and then you can click on the OK. And this is for the IV calculation, electron density, potential, conductance. So whatever parameter you want to analysis, you can select and then you can click on the generate file. This is the project window where input and output file will be shown, and this is the property window where the property of a whole structure, a single structure you can see, and this is the job manager.
What about the gate voltage?
Yes, yes, I can show you. Like suppose if you want to include some gate voltage, so you can click on the simulator, go into the NanoDCAL, and this is for the transistor. If you want to make a transistor, here you can also define the gate voltage, biasing voltage, and if you want to include some thickness, here you can see this is the gate region.
Okay.
Also you can include your gate voltage, like suppose 0.2, 0.4, 0.6, so whatever value you want you can put. And this is the biasing voltage, and this is the source point, like where you want to, like left one, right one. And suppose if you want to change the gate region, you can see gate region has been increased in the left region.
Okay.
And where you want to see your gate type, like this is the bottom and top, front and back. You can see this is the front and back, and this is the top and bottom. This is for the transistor calculation, 3-probe device structure, and if you want to include some voltage in 2-probe device structure, so here you can see this is the SCF input, and also include the voltage. Here you can, like this is the left one and this is the right one.
Sir, hello.
Yes sir.
I am requesting you kindly show one or two IV calculation. Okay.
1 or 2 means sir?
Means means IV calculation, IV characteristics. Okay.
Yes sir. I,
One or two value will work. Okay. Means I want to see one proper calculation. Means how it works, how to get the result, how to see the graph. That's I want to see.
yes sir, definitely I can show you. Also you can change the gate voltage here. Either from here you can select the gate voltage, or you can go into the simulator. Here you can change the gate voltage. This is for the left electrode, right electrode. So in this session I will show you how you can create a device structure, and in second session I will show you the property, how you can calculate the properties.
Hello. Hello, sir.
Yes sir.
So, when you are selecting the device, all the calculations like density, effective coefficients, vacuum scale, these are being calculated for the whole device. Left electrode, right electrode, along with the molecule
Yes
and the
sir.
connector. All these things combined giving you the results. Is it right?
Yes sir. Yes sir.
Okay.
And if you want to show for the particular, like for the left electrode and right electrode, so you can go into the simulator,
Yes, yes.
NanoDCAL, and
That
this
I
is
got it.
analysis. Here you can select only for the left electrode. This value is for the left electrode.
Ah,
You can see this is the density of state, band structure, electron density.
and this one is only for the left electrode, not left electrode plus molecule.
Yes sir. Yes sir. This is only for the left electrode.
Okay.
And if you want to show for the left plus device structure, so you can select this device structure, and in device structure you can see this calculation will take from the left electrode input, output from the left electrode, and this is for the device part.
Entire device, right? That's what my question was. If we want to selectively study the left electrode plus the central region,
Yes.
Then
This
I guess
yes, this output will give you the output from this left one and this for the center.
no, no. Even now I'm getting confusion. I guess to answer the speaker's question, what we need to do, keeping the left electrode and the molecule and deleting the right electrode, then the whole device, whatever will be the result, that will be giving your expected result.
Okay, is there any option to keep the left electrode like a constant potential or something?
No, ma'am, no, ma'am. There is no point to keep the constant for the left and right one.
While doing the calculation, if we can fix the left electrode and do the further like right electrode for central region.
No, ma'am. I need to check this point, and then I will confirm you. How you can keep the left electrode constant and you can calculate right one and this center part. So I need to check this point.
Okay.
Since device calculation will take some times to calculate the property, so in this session I will show you the simulation, only simulation part, and in the second session I will show you the property calculation. And this you can see this is the two probe device structure. Yes.
Sir, if the central part is some ionic liquid or something, can we fix this molecule or something in the central region?
If you want to fix at this center region, yes ma'am.
Central part, if it is some liquid, like ionic liquid or something, if you want to specify the like left electrode, that lateral size measurement for that electrode size, that we can fix, right? So for the central region, is there any option for that?
I need to check these points for the center part, how you can fix this electrode or center region.
Okay. This is
Actually,
what is the
ma'am,
central region.
ma'am, I think I can try to give you the answer. Means how here the circuit is built. Here first, and yeah, here first the cathode and anode are selected. Then central region have made. But what you can do, you first create the central region. You can calculate all the things. Then you can add the electrode also. Okay,
Okay.
means yeah.
Yeah, for the specification central region, if it is a liquid one, how to specify some solvent molality or
After
something?
making device you can't
Fix
calculate the
any.
central region. So that I can get from here. Means after you making the device you can't concentrate on the central region, scattering region only. Okay, if you want to calculate the Venn diagram density of states, then you have to first create the central region. Then you need to calculate all the things, all the parameter you need. Then you can add
Make a device.
then you can create the device and make the and can check the device parameters.
Yes, sir. Here you can see this is the two probe device structure, and if you want to create a three probe device structure like a transistor, so you can go into the simulator NanoDCAL, and here you can click on the transistor part. And if you want to make a four probe device structure, so this is the gold one. First you need to make a supercell of these gold atoms. This is the supercell, and then you can click on the build option. And this is the XY view. can select and you can delete like that. And this is the ZX view. For making the 4-probe device structure, first you need to create a 2-probe device structure. Like if you want to include some vacuum inside this unit cell.
Sir, one question, sir, how to deselect a particular atom only by left clicking?
Once moment.
That is how you made the tip. That is only by deselecting a particular atom.
Yes. You can select all these atoms.
Okay.
And control, and you can deselect this one, and then you can click on.
Deselecting by control.
Yes,
Control left click.
yes, control, and then
Okay.
you can click on the delete atom. And suppose if you want to create a vacuum inside this unit cell,
तो रात को सीख रहे हो
so in the direction of
सुना तो
A,
रात
you
के
can
कलर
see
डिलीट पूरा है
54 times, and in the direction of B also
रात
40,
में 11 बजे फोन करो डिलीट पूरा एलिमेंट्स का भी
and then you can click on the build option. To make it centrally fit, you can click on the center option, and you can click on center along A, center along B,
डॉक्यूमेंट टाइम तेरे पास
and then again you can select all these atoms, and then you can click on the mirror atoms, and in the mirror atom you can define the normal vector x, y, z, whatever value you want, and this is the distance. This is the 14 angstrom, and you can copy this sequence, click on apply. And then again you can go into the convert to crystal options, and increase the vacuum in the direction of C, so that both the electrode in between the unit cell. You can see both the electrode in between the unit cell, and then you can click on the build option. Then you can select all these atoms, Control C and Control V inside this unit cell. Control C and Control V inside this unit cell. You can select all these atoms, and then you can go into the rotation option, and this is the left one. And if you want to make a top and bottom or front and back, so first you need to rotate these atoms. Also you can define the angle. This is the counterclockwise z axis. And then you can click on the recalculate linker one, and again you can select all these atoms. You can go to the move option, and here you need to define the distance, and then you can click on the move right. And if you want to add some molecular structure in the center region, so you can import this molecular structure from the database. Either you can create from this molecular builder, this is the porphyrin phenylacetylene molecular structure that I have created earlier. And then you can select all these atoms, Control C, and then you can control V inside this unit cell.
देखना 1130 है, 80 रुपये से कम है, मतलब 77%। और हमारा जो FR
You
है
can
वो
select all
80
this
रुपये का, ठीक है।
molecular
अगर आप
structure,
उसको
and then you can go into the
880
center
का भी
region.
बेचोगे, 100 रुपये मान के चलो, ज़्यादा नहीं, 880 का। सर मैं क्या कह रहा हूँ, कहाँ 1130, कहाँ 880?
And suppose if you want to make a rotation of this molecular
मतलब
structure,
वही चीज़
so you
FR
can
वाले
select all this molecule,
तो सर आप क्वालिटी
go
दिखवा
to
दो
the
ना,
rotation option,
मैं क्या कह रहा हूँ, सर सेल्समैन वही है,
and here you can define the angle, and whatever position you want to make a rotation,
मगर
you
एक
can
क्वालिटी
select and you
बेचो,
can rotate.
वही चीज़ है सर। एक बार जब तक आप बताओगे नहीं उनको, उनको दिखाओगे नहीं वो सारी चीज़ें, तो वो कैसे मानेगा? कस्टमर होता है सर, मैं क्या एक बात बता देता हूँ आपको, कस्टमर ये नहीं देखता है कि सस्ती है तो अच्छी होगी, वो सोचता है सस्ती है तो चीप है, मतलब क्वालिटी बिल्कुल लो है। अगर
This is the
नहीं है
counterclockwise
क्वालिटी
y
अच्छी है, ये
axis.
चीज़ सोचता है कस्टमर हमेशा। आप कोई भी चीज़ आप खुद से लगा लीजिए, आप वही चीज़ 1100 रुपये की लाई मॉल से, कोई पेंट, ठीक है, वही चीज़ आप नॉर्मल शॉप से 500 रुपये की
And if you want to
लेंगे,
move
बट
this
आप खुद
molecular
कहोगे
structure,
भाई ये मॉल से आई है तो ये ओरिजिनल पेंट है, खुद सोचोगे इस चीज़
so
को।
first you need to
और वो
select all
500
these
रुपये का
items
अरे वो वही है,
and go
आप
to
किलो
the
के हिसाब से ले आ
move
रहे
option,
हैं, आप खुद सोचो नहीं सोचोगे इस चीज़ को।
and here you can set the position
प्राइस
to,
मैटर करता है, ओरिजिनल और लोकल क्वालिटी।
and if you want to add a sulfur atom in between these two atoms, you can select these two and click on the add a new atoms.
मांग कस्टमर की तो
So
100%
similarly here you can
रिक्वायरमेंट है,
add,
आप बनाओ उसको।
select this one
भाई
and
आप
click on the add a
ड्रेस
new
क्यों खरीदते
atoms.
हो, उनसे पूछो क्यों खरीदते हो? क्वालिटी अच्छी इसलिए खरीदते हो या
You can
महंगी
select
इसलिए
and you
खरीदते
can
हो?
click on
आप
add a
बताओ,
new atoms.
महंगी इसलिए खरीदते हैं या क्वालिटी अच्छी इसलिए खरीदते हैं?
This is the default
दोनों
gold
चीज़ें हैं,
atom is
बट मेन चीज़ है
selected.
क्वालिटी। क्वालिटी अच्छी तभी तो प्राइस
You
ज़्यादा
can
होगा।
select all these gold atoms
तो वही है, जब तक आप अपनी क्वालिटी नहीं
and then you
बताओगे
can
तो
click on
आपको
the
कौन सी
replace
चीज़
atoms.
बताएगा? जब तक आप किसी चीज़ की क्वालिटी नहीं बताओगे
This is the
तो
sulfur
उस चीज़
and
को
then you can click on the
सोचेगा
OK.
नहीं।
You can see
ये सर मैं क्या कह रहा
sulfur
हूँ,
atom
एक
has
ही
been
सेल्समैन
replaced.
अपनी चीज़ का बड़ा चढ़ा के क्यों कहता है? क्योंकि उसको उसमें मार्जिन दिख रहा है।
And to make a
आप उसे
connection between
500
these
रुपये
two,
उस पे
these
एडिशनल
three
कर
and
दो
these three,
और
you
500
can
से
click on
500
the
रुपये और
recalculate linker
सर मैं
one.
क्या कह रहा हूँ, आप एक वायर के डब्बे पे कम से कम
You
150
can
से
see
200 रुपये,
all the atom has been interconnected by the covalent
150
bond.
200 रुपये जब आपको मिल रहे हैं तो आप थोड़ी चीज़ नहीं बोलोगे भाई, आप 15 मिनट खर्च करने हैं बस, ज़्यादा नहीं। और
And to
वैसे
make
भी
a
सर
4
आपको
probe device structure, you can click on the convert to device option,
भाई छोटे मोटे काउंटर्स पे तो यही करवा
and
देगा।
here you can define the
कुछ होते
electrode
हैं ना,
parameter.
गांव वाले के मंथली 50,000 के सील करवाते हैं, 30-40,000, तो वो 2-3 बंडल लेते हैं, तो वो तो मटेरियल वो ही नहीं करवा देगा फिर। रहा इलेक्ट्रिशियन मीटिंग करवा दी किसी टाइम, तो इलेक्ट्रिशियन को भी
This is the left electrode value, right electrode, and this is the bottom and top. You can click on the preview option. You can see all the electrode has been
करने का तरीका होता है, पैसे
generated.
बनते हैं सर, आप लोग बताएं। थोड़ा सा वही है सर, मेन चीज होती है,
This is the left electrode, right electrode,
आप बचा रहे हो
top electrode, and this is the bottom electrode. And then you can click on the build option.
अगर आप एक चीज पे कमा रहे हो और एक चीज पे कमा रहे हो आप 60 रुपए, बट निकल रहे हैं 100 पीस।
So from this device studio, you can simulate up to 6 probe device structure,
ठीक है, 100
2
पीस
probe device structure, 3 probe device structure, 4 probe, and 6 probe device structure you can simulate.
100 पीस ले तो 6000, तो 6000
अच्छा sir, can you go to two probe device structure?
5000
Yes sir.
पूरे दिन
Two probe device structure. Can you go to two probe device structure? I
Yes.
want to ask something. Okay. So now how to select the voltage, electrode voltage?
हमारा जो
So you can go into the simulator,
और जब डिमांड बढ़ जाएगी सिर्फ आपसे
NanoDCAL.
पॉलीकेट
Here you can see this is the SCF calculation and this is the electrode.
महंगा भी बता दी ना,
Electrode. Okay. Now you tell me means how I should write the voltage randomly. Should I?
5 रुपए में गया
Yes, you can see
और यहाँ पे सिर्फ आपके पास रहेगा, तो
0.5,
आप जितना दोगे ना वो उतने में
whatever value you want, you can put into this and you can click on the generate
सर
file.
देखो एक बार जब कंपनी जुड़
Once
गई,
you,
आपको सर
yes,
ये समझ लीजिए अभी स्टार्ट
Okay. Sir, please continue. Then how to run it? How to
then
get the result?
yes, this is the first you need to run this electrode and then you can see, and this is the SCF for the device part. Then you can run this one, and
No,
then you can also
first I need to run the
left code.
SCF file, right?
Yes, yes.
SCF of what device?
हाँ सर
First, you need to run the SCF for the left one, and then you need to run the for the device part.
एक लाइटिंग बोर्ड मिलेगा
Means
आपकी शॉप पे
I
लगेगा
want to see one
वहाँ से
result. Means
मिलेगी
how
आपको
to complete the simulation. Means
बैग में
for
लगेगी
just for the one value.
मतलब मार्केटिंग मटेरियल सर मैं क्या कह रहा हूँ अगर आप
Can you
जैसे
show? Means
मतलब जैसे मार्केट में
just
जाते
for the one
हैं
value.
आपके
Means
पास
when the
स्केल्स
right
है
left elected is
आपके
zero
आने
point
वाले समय में
0.5.
मीटिंग
Means
मिलेगी
what you have set up.
प्रेस भी लगाओ
Now just
इंडेक्स लगाओ
show how to calculate it.
आपका सिर्फ गैंग
Sir,
बॉक्स
here
लगाना
you
है
can see, and the total number of atom is 17, and it will take some time to calculate the property. So in the second session, I will show you how
Okay.
you can calculate.
Okay. Means any small system. Means I just want to see the process. Means
Yeah.
after getting the result, how to see the result. That's
Okay,
the
sir, no,
thing.
sir. In second session, I can show you how you can
Okay,
get.
means any one element, two element, one atom, two atom, that will be do. Means I just want to see the how to do it. I just want to learn. And sir, another thing I want to see means last session I also mentioned how to see the result in the MATLAB, means especially total energy.
Yes, sir. I will show you. In second session, I will cover all this point, whatever
Okay,
you
okay,
ask.
okay, okay.
आप भेज रहे हो
Thank
दो
you,
मिनट
thank
बस
you.
दीजिए
Okay, sir.
Hello, sir.
Yes, sir.
So initially we were doing the calculation for the left electrode SCF. Then we were telling that right electrode is just analogous to the left electrode. That's why we need not to do it twice.
Yes, yes.
Then we were going to the device. So if we do the device SCF at first, will it be wrong?
No, sir, no, sir. Because in the device SCF input, you can see this is the device input.
Hmm.
This will take the output from the left electrode. This is the for the right electrode. Then it will give the output from the whole structure of this device. Whole device structure. Output from the whole device structure.
But the molecule part was not included there
Where, sir?
in the SCF input file.
Sir, in here you can see.
लेकिन आपकी जो फेस है ये कहाँ जाएगी फेस वैल्यू को तो समझते हो आपके पास आपके ही जो कस्टमर है ना वही आएंगे
This is the molecule.
पड़ोस वाले कस्टमर
This is the molecule and their Cartesian coordinate point.
लूट रहा है और वैसे सर आप इतने साल से वो मार्केट में तो ऐसा नहीं है कि जैसे कोई व्यवहार के ऊपर आते
Sir,
हैं
is there any option to find the charge transfer between the left electrode and the
अब ये
body
आएंगे
center
व्यापार
part?
में तो उससे पहले
Yes, charge you can also calculate. Like you can go into the simulator, NanoDCAL, go to the analysis part.
अपना उनका एक मतलब रिलेशन बन जाता है
Here you can see this is the charge.
आप ही रहते हो तो कस्टमर
Means you will get a particular value for that in the results. Or the charge transfer plot we will get.
Just one second.
मतलब बात ये है कि पॉलीकेल इतने साल से आ चुका है मार्केटिंग कर रहा है उस चीज पे इसका जो है पैसा ज्यादा है ये कंपनी अभी आई है मार्केटिंग अभी डेवलप है क्वालिटी इतनी अच्छी दे रहा है मार्केट में आने के लिए पैसा इसने कम कर रखा है दोनों सेम चीज बट अभी क्या है ये नई है ये आ रही है ये डिमांड में चल रही है इसलिए इसका प्राइस ज्यादा है इसलिए इसका प्राइस कम है बट क्वालिटी अगर देखोगे दोनों में सेम बस यही चीज है सर आपको एक उनको समझाने का तरीका जो है ना एक बार नहीं आ जाता सर किसी के माइंड में सर इसमें जो कॉपर है ना
हेलो
इस चीज की तो मेरे को देखो मैं कहीं नहीं
Like if you want to show the device property and device output property,
बताते हैं कि 99.7
so it will take some time to calculate. So I can show you some yes.
क्योंकि लैब से टेस्ट हो रहा है
So I have created some project earlier.
आप किसी गवर्नमेंट काम में लगाओगे ना वायर को जैसे कोई स्कूल बन रहा है या कुछ बन रहा है तो वहाँ पे भी जो है सर्टिफाइड है आईएसआईसी सर्टिफाइड है आईएसओ सर्टिफाइड है और आईई यूरोपियन सर्टिफिकेशन है इसके पास तो उस चीज के लिए पहले से और दूसरी चीज बता देता हूँ रिप्लेसमेंट अगर आप
Here you can see, and this is the left electrode, right electrode, and this is the alkyl molecule. And this is the property that I have calculated. This is the density of state. You can click on the show view. So this is
Hello,
the
sir.
yes, sir.
How to calculate the ZPack input, ZPack property? Can you show ZPack model?
You can click on the density of state, right click,
No, no, ZPack one.
see back.
Ah,
Yes, sir.
above. Yes,
This is the
that one.
Seebeck coefficient. You can right click and click on the show view.
Hello, how
And
to calculate that one? I can't see that in analysis part.
was 1 second, sir.
Okay.
वो तो फ्री कहते कोई मतलब नहीं, उनको सस्ता चाहिए होता है। तो हमने वो फ्री जो आपकी 4 सीरीज आई ना, वो जो नॉन मॉड्यूलर आती है ना, उसी रेंज में निकाल के ये मान के चलिए सर 13 रुपए में आपको हम कुछ प्रोवाइड करा रहे हैं 10 रुपए का। बताइए 50 रुपए में जो 120 रुपए की मॉड्यूलर प्लेट मैं क्या कर रहा हूँ सर, इतनी की मैं क्या कर रहा हूँ, इतनी की क्वाड मैं क्या कर रहा हूँ, इतनी भी मैं क्या कर रहा हूँ।
Here you can see this is the simulator, NanoDCAL, and this is the analysis part. Here you can see this is the Seebeck coefficient. So once you run this, you can first you need to generate this file. Here you can see this is the SCF input file, and this is the parameter of this Seebeck coefficient.
Okay.
And then you can click on the run option, and here you can click on the run option, and once this calculation has been finished, their output will generate after the calculation finished.
Okay, sir. Yesterday I tried the 2D material system.
Okay.
So in that I can't see that ZPack. Only they shows only GT values. Then only I asked the question
Okay.
in 2D materials. Take some 2D material example graphene. This
Right.
one is okay.
Okay. So I can show you. This is the graphene,
Yes, okay.
and if you want to make a supercell, first you need to click on the redefine crystal.
Yes, sir.
And if you want to calculate the Seebeck coefficient, or you want to
Yes.
calculate the Seebeck coefficient,
Yes, sir. Here they only show GT value, not ZPack.
so sir, Seebeck coefficient is for the device part, and so first you need to convert into this device part.
Generally, people are calculating ZPack coefficient in the 2D materials, not for some device part. Take a monolayer, they calculating ZPack, but now you convert it into device.
Sir, you can see in simulator NanoDCAL analysis part, Seebeck coefficient is not there for the crystal part. But
Okay, go for the GT one, ZT. value.
yes.
Then that the first option asks the primitive cell. What does that mean? Primitive cells.
Sir, in this, sir, because we have provided you the trial license, so and this ZT is not in the for the trial license. Yes, this property you can also calculate in full version,
और वाइट
but
स्टोन
this is property is restricted in the trial license.
This is not a full one. No?
Yes, sir.
This is not full version. It is trial one.
Yes, sir. We have provided you the trial license, not the full license.
Oh, okay, okay. Okay, sir.
कोई नहीं मैं आपसे आप दोनों दोनों में से दिलवा दूंगा एक एक बॉक्स पैक करके
And
Sir,
like if you want, yes.
चार पीस
uh, when I am trying with the version which is already loaded examples, no? So it is opening. But when I am uploading my ritual refinement file and trying to follow the same steps, the output file is not generating.
Which file you have imported, man? May I know?
I have done it for the nickel ferrite. So I have downloaded the CIF file from the net and trying to do the same thing, but the output file is not generating.
Definitely you can see like I have some SCF in just 1 second.
Sir, wait. Yeah, it took long time to generate that file. Now it just opened right now. It just opened now, so thank you. Maybe it is taking long time to get the output file in my computer.
Okay, yes.
Okay, thank you.
Sir, what about charge transfer?
So for the charge output, first I need to open my MATLAB.
I request to the participant kindly wait for question answer session after 30 minutes. Let it complete the speaker for the demo session. Then after that you will ask the questions. That will be more better, because otherwise the speaker will not be able to complete the demonstration which he wanted to present completely. So I request to all the participants kindly after 12:30 you can ask your questions. Thank you.
Like here you can see if you want to import some CIF file, so you can go into the import option, import local, and I have some CIF file. You can see this is the CIF file, so you can select this CIF file and just you need to click on the open. Here you can see the CIF file has been imported directly. And if you want to show the device property, so I have created some project earlier. You can see this is the device, two probe device structure, and this is the property that I have calculated, and this is the density of state. You can right click and click on the show view, and if you want to zoom particular point like -5 to 5, so you can select and you can show like that. And you can easily export your raw data, so you can click on the export option, and here you can see whatever format you want like PNG, JPG, BMP, PDF, TIFF format, EPS format, text format, so you can select and you can import easily. And suppose if you want to in PDF format, and then you can click on this save. You can see, and this is the density of state in PDF format. So you can easily export your raw data in any format. And this is the transmission. You can click on the show view. This is the transmission coefficient with respect to energy, electron voltage. And also you can see this is the current voltage calculation. So this output file will open in the MATLAB. So you can see my MATLAB has been opened. And here you need to relocate your project where your project have been set. And this is the total electron density. So this is the 3D viewer. And this is the 2D view along x-axis, y-axis, z-axis. And this is the planar display. If you want to show the stereoscopic display, so this is the stereoscopic display along z-axis, y-axis, x-axis. And this is the 1D view along the xy plane, yz plane, xz plane. And this is the effective potential. Of this effective potential. So here you can see you can increase the density like that. This is the 3D view of this effective potential. If you want to show the 2D, and this is the 2D view along x-axis, y-axis, z-axis.
Participants, just kindly wait for 1 minute.
So sorry for this disturbance, and there is some network issue. I would like to share my screen.
आइटम मैं आपको बता देता हूँ अपने पास सर तीन रेंज में वायर है अपने पास एक तो है इको बैंड जो बिना पैकिंग के आता है दूसरा है एफ आर वायर तीसरा है एच एफ एफ आर
Here you can see I have relocated my project, this device
एच एफ एफ आर है
IV calculation, and here I have calculated at 0.1 voltage, 0.3 voltage, 0.7 voltage, and this is 0.5 voltage.
एफ आर वायर का कोडी पेपर खरीदोगे 1100 रुपये तक का आएगा शायद 1050 1100 रुपये तक का आपके लिए ही और ग्रेड वायर को कम से कम 1
Here
mm
you can see at a 0.1 voltage, and this is the current voltage dot my file. So you can double click on it,
आई थिंक
and here you need to type the data,
लगभग में बताया अप्रोक्सीमेटली कल भी मेरी बात हुई थी कितने रुपए का पड़ता है
and this is the output at 0.1 voltage and minus 0.1 voltage, and this is the I1 and this is the I2.
नहीं क्वालिटी की बात कर रहे हो सर है मतलब अच्छी क्वालिटी में जो देखिए ठीक है क्वालिटी भी तो मैटर करती है एक तो होता है सर कॉपर वायर दूसरा होता है पीवीसी कौन सी यूज करते हैं कॉपर कौन सा यूज करते हैं एल्युमिनियम तो नहीं मिलाते हैं
Here you can see voltage is 0.1 voltage and current is minus 4.3 into 10 to the power minus 8, and this is the voltage V2 minus 0.1, and this is the current minus 4.3 into 10 to the power minus 8.
आपको पता है कि वायर ऐसे ऐसे भी आ रहे हैं विदाउट पैकिंग में भी आ रहे हैं पैकिंग में भी आ रहे हैं बहुत सस्ते सस्ते हैं मार्केट में बट वही है जब सस्ता बेचते हैं ना आपको कस्टमर को ये लगता है यार
And this is the
समझ रहे हो ना क्योंकि सस्ती चीजें हमेशा लोग
current voltage curve dot net file for the 0.3 voltage.
क्वालिटी क्या है क्या नहीं है अगर
So you can click like that, and here you need to type the data.
महंगा है नाम हो गया है मार्केटिंग में पैसा जो लगाया वो प्राइस में बता दिया है क्वालिटी
Here you can see the voltage is 0.3 and the current one is 6.22 into 10 to the power minus 8,
हम अभी आए
and this is the voltage minus 0.3, and this is the current minus 6.22 into 10 to the power minus 8.
तो हर चीज में टाइम लगता है वही चीज है तो अपने पास तीन रेंज में वायर है तीन रेंज में ही अपने पास मॉड्यूलर एसएसडी है फर्स्ट है हमारी चार्ट सेकंड है मून सीरीज थर्ड है हमारी स्ट्रेंथ सीरीज तो जो 10 एम्पियर का स्विच है हमारा चार्ट सीरीज का वो 13 रुपए का आपको पड़ता है डिस्ट्रीब्यूटर प्राइस चार्ट सीरीज का
And again you can see this is the voltage 0.7, and this is the current 1.08 into 10 to the power minus 7, and this is the voltage minus 0.7, and the current one is minus 1.08 into 10 to the power minus 7.
तो फिर भी मतलब
And to plot this
प्राइस
IV calculation, IV graph, so first you need to click on the new script,
ये फ्लैट है ये
and here you need to write the script for the IV calculation.
हाँ और ये अपनी मून सीरीज है भाई कितना लिखना है ये मून सीरीज मतलब बहुत प्यारी सीरीज है और
So first I want to make the comment. So
उसके बाद इसमें सारा है अपने दोस्त भी है मॉड्यूलर रेंज बॉक्स है उसके बाद अपने पास है हीटर है
and here you need to write the voltage value, current values, and then you can plot this IV data. Voltage equal to
मेन बॉक्स है अपने पास इमर्शन रॉड है अभी भी नहीं है
0.1, 0.3, 0.5, and 0.7,
पता है अभी हाफ किलो में चल रहा है आपको पता है हमारे पास
and this is the value of current.
और सेम प्राइस है प्राइस भी ज़्यादा नहीं आपको 61 रुपये में 7 वॉट और 62 रुपये में 9 वाट ये पड़ जाएगा मतलब सेम आपका जो है हाफ किलो
Here you can see the voltage is 0.1 is
ये है सब पूरा और आने वाले समय में अभी हम
current one is say, so you can paste this value.
बीच थोड़ा टाइम लगेगा पेस्ट करने में बस डीएलडीसी फैन और मतलब जनवरी एंड चल रहा है
And again you can show this is the for the 0.3. This is the 0.7, and if you want to show the for the 0.5,
कोई नहीं सर, अगर आप आज स्टार्टिंग में अगर करोगे ना तो मैं अभी जाता हूँ और एज अ सैंपल आपको थोड़ा थोड़ा मटेरियल अभी मैं दिखाऊंगा, जिससे क्या है ना आप स्टार्टिंग में आपकी क्या पूरी रेंज आ जाएगी। पूरी रेंज में क्या है कि कोई अगर इलेक्ट्रिशियन से काम हो तो उनको वो समझ में आ जाएगा। तो अगर कोई भी इलेक्ट्रिशियन को लगाना है तो हमारी कंपनी क्या है, कम से कम नहीं तो 2 से
here
3
there
मीटर
is no
की
voltage
मीटिंग
defined,
वो
so
करता
that's
है,
why
ठीक है। उसके बाद 2 से 3 मीटर की डिटेल में
here
करता है।
showing 0, 0, 0.
ये रेवेन्यू प्लस कम से कम
But once you define the voltage and simulate the property, simulate the IV
दो
calculation,
की मिलती है,
then the output file will be
तो
generated, and then you can plot the data.
थोड़ा है कि नहीं कि ये आपको पोजीशन चाहिए, ये नहीं रहेगा कि आप अकेले लड़ रहे हैं, कंपनी आपके साथ लड़ेगी और फुल सपोर्ट रहेगा मार्केटिंग को लेकर। आपके पास लाइटिंग बोर्ड, टी शर्ट्स इलेक्ट्रिशियन के लिए, टूल किट, टूल बैग, मतलब मल्टीपल चीज़ें जो है कंपनी प्रोवाइड करती रहेगी। और आपको जो है 5% इंसेंटिव और 2% आपका जो है एनुअली जो लास्ट में आता है पूरा इंसेंटिव रहेगा, जितनी आपकी लागत पूरी सेल की तो उसका 2% आपको मिलेगा।
This is the current value of this for the 0.7 voltage, 0.5, 0.3, and 0.1.
सर मैं तो ये चाहता हूँ कि एक बार हल्का सा और देखिए, मतलब ये है कि कंपनी में ये है कि आपका मतलब काउंटर ऐड हो जाएगा, जिससे आप क्या है 5% जो इंसेंटिव मिल रहा है ना वो सर दिसंबर के लास्ट हमारी लास्ट मतलब
And
लास्ट
here you need to write the script for the plotting the graph, like plot voltage,
तो फिर भी ऐसा हो जाएगा कि भाई साहब ये
comma,
ज़्यादा से ज़्यादा
current,
एडिशन करेंगे। आपकी तो आज सर 2200 डीलर हो चुके हैं, मतलब पूरे जो है उसमें
comma,
एनसीआर में और यूपी में। आने वाले समय में सर पूरे इंडिया में कवर करेंगे। तो मैं चाहता हूँ सर अगर ये जो हमारा मैं वो क्या है सोल्यूशन
and like where you want to show the voltage value at x-axis, y-axis, where you want to show. So here you need to define the x levels.
भी उसमें जो है ये थोड़ा हमारा जो ग्राफ है फर्स्ट ईयर का जो ईयर
I want to plot this data, voltage data on the x-axis and the current data at y-axis.
मतलब प्राइस से अलग, प्राइस जो है डिस्ट्रीब्यूटर प्राइस तो रहेगा आपको भी और 5% इंसेंटिव आपको जो है अलग से मिल जाएगा। और एक लाइटिंग बोर्ड आपके शॉप के लिए तुरंत मिल जाएगा, एक लाइटिंग बोर्ड जो है वो आपको तुरंत मिल जाएगा।
And this is the current at y-axis. Also you can include the title of this graph.
हाँ नहीं नहीं, रविंद्र के पास पूरा कैटलॉग भी है और उसके पास प्राइस लिस्ट भी है, वो आपसे बात कर लेंगे और कर लीजिए सर, क्या बात देख लीजिए तो रविंद्र सर से लिस्ट बनवा लो, आपके पास सारे कैटलॉग यही है।
And then you can click on the run option. And here you need to save this project. And once this script has been run, and then the output will be generated. You can see this is the graph between voltage and current. This is the current value and this is the voltage value, and this is the result. Here you can see current value is 0.3 and voltage value is 0.3 and current value is 6.22 into 10 to the power minus 8. And this is the voltage 0.1 and this is the current 4.30330 into 10 to the power minus 8.
अपना वायर का दोनों का है, हीटर है ये, इमर्शन वाला है।
So IV calculation is also possible. You can see, and this is the IV data, IV graph.
मेरे पास है वो उसके पास में तो इमर्शन रोड में ज़्यादा नहीं, एक ही मिनट हीटर का है जो का
चीज तो चाहिए।
And if you want to calculate the spin current, So for the spin current, I have calculated the project earlier. Here you can see this is the graphene nano ribbon, 2 by 2 graphene nano ribbons, and I have calculated the spin current for this structure. Here you can see this is the current voltage curve.mat file, and this is the voltage V1 equal to 0 and current one is minus 1.50 into 10 to the power minus 5, and this is the voltage 0.2 and the current one is 1.50 into 10 to the power minus 5. Here you can see I have imported some spin calculation. So this is the voltage current and this is the spin current. This is the spin up and this is the spin current, spin down current. And this is the script for this spin current. So you can see this is the spin current, this is the current value, and this is the voltage value. So once you simulate the property from this device studio NanoDCAL software, then the output data will be generated, and then this output data you can import in the MATLAB, and then you can plot the graph. And if you want to show the conductance and current, so just one second.
पूजा लगता है कि 6 घंटा की ड्यूटी है काम है वो भैया थोड़े परेशान विनोद कहियो विनोद होते विनोद
This is the conductance and current.
6 घंटा की ड्यूटी काम है जैसे घर का कर
You can see this is the value of conductance, this is the current, and this is the applied voltage.
नहीं मिलेंगे तो मैं धक्के खा लूँगा 1 साल 2 साल पीछे ना मिल जाएंगे न्यों ना मन समूरी ना कहाँ मिले वो जैसे पता ना कहाँ करेंगे वो कहाँ करना पड़ेगा ऐसे में जय हो लगा
This is the current description. Conductance side lead 1, lead 2, and this is the applied voltage lead 2. So if you have any query, so you can unmute your mic and ask me a question so that I can try to resolve, or either you can paste in the chat box. So anyone has any issue?
Sir, I didn't get the charge transfer value.
For the charge, 1 second. This is the charge.mat file. You can double click, and here you need to type the data. Here you can see the total voltage and total charge is 411.0.451, because I have not applied any voltage and any current, and this is the default parameter because I have not selected any parameter in the simulation part. Once you Once you define the parameter, then your output will be generated and then you can see the output data. But charge is also possible in this software.
Means we will get the charge transferred between the left electrode and the molecule, right?
Yes.
The values or the plots we will get.
In the MATLAB file you can see the default parameter is selected. So just one second. Once you define the like theta, phi, spin, magnetic moment, then the charge transfer will be plotted.
Okay.
Hello, sir.
Yes, ma'am.
Sir, myself Devi. I have one doubt, sir. Sir, actually, I tried to stimulate by VASP using VASP, but I can't calculate it, even though band structure and device at all I can't calculate because they ask some potential. But I selected B potential, but I can't generate the file also. If you please show how to calculate from
Ma'am,
VASP.
yes. Like this device is to do make an interface, only interface with VASP, not for the
Okay.
background calculation engine. So if you want to run this VASP input file, then you need to run in the VASP software. So first you need to run in this VASP because this makes only the interface, not for the background calculation engine.
Okay, sir. Sir, you just try AMD, sir.
Here you need to select the parameter and then you can click on the generate file. Pseudo potential. So any pseudo potential you can select. Suppose I have taken this one.
You can select that folder, the pseudo potential folder. You can select it. Yeah. So not.
Yes, you can select like that and you can click on this generate file. And this input file you can run in the VASP software, not in this NanoDCAL software.
Okay.
only you can generate the input file.
Okay, sir. Thank
Sir, is there any option to assign some charges to the electrode, like surface charge density, charging and uncharging of electrodes?
Like charge density for the device structure, for the left one and right one.
Yeah, surface charge density, like some particular value sigma is equal to some microcoulomb per centimeter square, some particular value if we can assign.
अभी बहुत दूर वाला कुछ बोलने वाले हैं, बहुत दूर दूर से बोलना चाहते हैं, बहुत दूर दूर वाला देखे तो गए, ये तो वही है ना, पेमेंट करो, पेमेंट अप्रूव हो गया, पैसा नहीं है, पहले पूछ वही तो कुछ कहना तो चाह रहे हैं ये.
Ma'am, I need to check this point where we can add this from Coulomb forces in this charge part. So then I will confirm you.
Okay.
Because charge calculation is also there. You can see this is the charge.
Okay. But prior to the calculation, if we can assign some particular values, surface charge density, the left and the right electrode.
दुबई साहब बोलना चाह रहे हैं क्या, बोलो यार, हाँ बोलिए.
Ma'am, I need to check and then I will confirm you.
Okay, okay. Then what about the optimized geometry?
Yes, if you want to need some optimization from this structure, so first you need to click on the simulator, go into the NanoDCAL, and here you can click on the relax. Here you can choose the relaxation method like MD molecular dynamic, conjugate gradient.
This MD will work, right? This one.
Yes, yes, ma'am. I can show you.
Means
Like
for other MD calculation, we need to go for the lamps, right? But what about this MD?
one second.
इनसे पूछ रहा है कि सही बनाया या इसमें कोई बढ़वाना है या कोई घटवाना है.
Like this is the gold. If you want to make a optimization, click NanoDCAL, go to the relaxation part, and here you can select the MD or CG, whatever you want, and then you can click on the generate file. Once you click on the generate file, the relax.input file will generate, and you can click on open with. Here you can see what parameter I have defined, and method is MD molecular dynamic, and this is the convergence criteria volt 0.03 electron voltage per angstrom, and this is the basic settings. Then you can click on the run option to run this job, and once this calculation has been finished, the relaxation dot output file will generate. So I can show you. Wait for the calculation.
For this MD calculation also, we can set the analysis part, right?
Yes, ma'am. Yes, ma'am.
ये
Okay.
शुरू
What's
तो
the
ले ली
difference
भाई,
between
पूरे
this
सेट
MD
साइड
and
ले
the
ली है,
lamps?
ये तो
It's the
VIP
same,
वाले में
right?
जाएगी.
Yes, ma'am. EMD and
What is the difference between these MD calculations and the lamps? They're the same MD calculations, right?
वाला वाला चार्ज वाला.
there's
You are using the interface, right? Lamps, two lamps we have to do.
yes, this device studio make an interface with WASP, Gaussian, Newgem, Quantum Expresso, lens,
Okay.
whatever.
But directly from here we can run the calculations, right? MD.
So do we have to install all this software, WASP, Quantum Espresso and MATLAB?
Yes, yes. Because this device studio make only the input file. You can generate the input file, and
But now we are doing the MD calculations, right?
So
System
MD calculation, this lamps interface is there, where you can perform the MD calculation in lamps. This software can generate the input file.
But now we are doing the empty calculations, right? What is that then?
Basically,
So
here only the that feature is given where conjugated gradients are preferable. MD
Okay.
calculation, LAMPS is required, and no need to do the installation of WASP, Quantum Express, or Newcham. It will generate the input file for WASP and Quantum Express and all the software. Installation is not compulsory. Only Device Studio NanoDCAL installation is necessary. Apart from that, it can generate the file for other tools, and it can import the file from other tool as well.
Okay.
MATLAB output, how we will see without installing this MATLAB?
MATLAB output either origin software, MAT file can get directly imported to either origin or in MATLAB. Without installing, it is difficult. But
Origin maybe that file, I think.
MAT file is there, XML DSF file that can be visualized in Device Studio. And this Nano Academic team is working to remove the dependency on
Yes, yes.
MATLAB soon.
That should be very good.
They are definitely working on it. They have confirmed to us. Probably in coming years, they will remove the dependency.
Okay.
Here you can see the gold atom has been relaxed and their output has been generated.
Okay.
And then you can click on the analysis part.
डीके तो वैसे ही का है क्या सुरती टी का प्रोफेसर
Whatever parameter you want to analysis, you can select and you can click on the generate file.
बर्थडे मना लिया भाई तूने
ना भाई मैंने
हाँ अब क्या मनाने जाना है तुझे
कुछ नहीं मना
हाँ
This optimized .xyz file is accessible, right?
तू खत्म हो
Yes, sir. You can right click on this.
कब तक
You can click on open with,
बचन दे
and this is the
And
optimize.
visualization.
Yes, ma'am.
Visualization.
तो छुट्टी पेट भर के मारी है
Visualization
यहाँ
of
तक
this
भर गया होगा
optimized
तभी खत्म
geometry
ना हुई हो
in any calculation like CG or something.
हाँ?
So after
पेट भर के
relaxation,
छुट्टी मारी पेट भर के
get the
Visualize.
structure of
Yes, sir.
optimized geometry.
इधर से हो गई थी ना
Yeah, definitely in coming version, it will also be visualized the optimized
11 को
structures.
चली कितनी को गई थी वो
So, yeah, in a coming 22 two version.
गई थी 15 को अगर 11 12 में जाती ना तो
15 को गई थी तू उसके साथ गया होगा
हाँ
तू कितनी को वापस आया
18 को
18 को पर तू यहाँ कितनी को आया
19 को
19 को
So basically, this software will not do the Gaussian calculation here. It can generate the file for Gaussian, length, VAS.
रोक दिया उन्होंने
और वो कहीं भाई मंदिरों
You can see this is the density of state after this relaxation.
चले गए फिर एक मंदिर है ना
Okay, sir, can you go to the MATLAB again? MATLAB.
Yes, this is the MATLAB.
How to load the data?
Here you can select. Here you can select your data, like where you can browse your data. Where this is the desktop folder.
Okay.
Where you have any project, so you can select that project. Like this is the my project, and you can select folder. After selecting, you can see this is the data.
Okay. For that, we need to download the MATLAB file, right?
Yes, sir. Yes.
Actually, I have access online, but it not allowing us to go anywhere apart from the MATLAB drive. Okay. Thank you.
So from here you can relocate.
Acha, from the origin also, can we see the result?
Yes.
Can you
This
show how to see the result in the origin?
Basically, we do not have the license of origin, but that MET file can be imported in origin, and then you can try to import. If you have license, you
How?
can.
Drag and drop?
There is import feature is there in origin.
Okay.
Once you click on import, and you can select that MET file and select that particular column, it will get it plot.
Okay. Thank you.
आपके कहने से मैंने 2 बार आपका डिलीट अपनी खुद मर्जी को करवाया है ज्यादा नहीं मैं सीधा बोल रहा हूं मैं तो ये तो नहीं कह रहा हूं कि आप 50 साल
So anybody has more questions, so kindly ask so that we can try to resolve. And in second session, the hands-on training is there. So that time you need to run this calculation in your software. So I will show you.
Now it's time to lunch.
है मन में तो सर देखो हमारी आपकी रिलेशनशिप क्या होती है, देखो टाइम पे आप हमारे काम आ जाए, आपके मेरे काम आ जाए, बस वही रहता है।
ये लग रहा है भाई लड़का घुसा क्या अपनी फोटो इसको ना उस पर लगा दो ना तुम नैनो
And suppose if you want to make a carbon nanotube based like this is the graphene nano ribbon nanotubes. So you can select this is the graphene nanotubes, and here you can see this is the default carbon atom is selected. And suppose if you want to make a boron nitride base, so you can select this boron, and here you can define the n and m value crawl vector, and then you can click on the preview. So this is the nanotubes, boron nitride base nanotube.
मेरा मोबाइल टूट गया था पूरा वाइट कलर का था ना ब्लैक कर दिया
And if you want to show carbon based,
पैसा नहीं जुगाड़ मेरा बदलते
you can see this is the carbon based.
जुगाड़ से वैसे तो वही है ना ईएमआई नंबर वगैरह सब वही है सेम मेरा ईएमआई नंबर सब कुछ वही करवा दे मेरा सब कुछ चेंज करा के बात है अब वो जुगाड़ तो जुगाड़
Here you can see this carbon nanotube is quite thin. So if you want to increase the length of this nanotube, so you can go into the build file, redefine crystal, and here you redefine the in the direction of the transport direction, and you can click on the preview. This is the 4x4 graphene nanotube. And if you want to make a graphene nano ribbons, so here you can see this is the graphene nano ribbon builder. You can also define the bond length, you can select the atoms, also you can passivate with hydrogen atoms. Here you can define the crawl vector and NM value, and then you can click on the preview, and then you can click on the build option. And then you can again redefine your crystal, and then you can click on the preview option. So this is the graphene nano ribbons. So this is the single layer. If you want to make a multi-layer graphene nano ribbon, so you can select all these atoms, and then you can click on the mirror atoms, and here you can select this is the XY. Go into the mirror option, and this is the XZ, the distance, and you can copy this checkbox and you can click on apply. And this is the multi-layer graphene nano ribbons. If you want to make a graphene nano ribbons and boron nitride based graphene nano ribbons and which are between two boron nitride, then first you need to create this graphene nano ribbons, and this is for the carbon based, and then you can again select this boron nitride based, and also you can send the bond length. And again you can read And then you can copy this boron nitride with graphene nano ribbons, and
स्पीकर होना है क्या? तुम उधर बोल रहे हो, इधर आवाज आ रही है। स्पीकर ऑन है क्या? स्पीकर ऑन है क्या? सबको आवाज आ रही है। तुम्हारी आना स्पीकर ऑन है।
you can see this boron nitride is sandwiched between two graphene nano ribbons. And then you can analyze the property, whatever property you want to simulate from this structure. And suppose if you want to make a device structure, so you can click on the convert to device option, and here you can define the electrode. And then you can click on the build option. And once you applied the voltage on the gate terminal, this device structure will be have like a field effect transistor. So for this you can go into the simulator, click on NanoDCAL, go to the transistor part, and once you can define the gate voltage here, then this device structure will behave like a field effect transistor. So if anybody has any questions, so you can unmute your mic and ask me a question. Because there is 2 minutes left in this session, and again we will join at 2 p.m. in second session. I think there is no more question. So
Yesterday we could not see the XML file for this band structure, so we could not feel the band structure in our own.
like if you want to calculate the band structure, like this is the board.
In our whatever we have done as a hands-on experience yesterday. In your case, it is okay. You have shown all these things.
Okay. So sir, what were problems are in your software? Can you share?
I am not getting this XML file generation.
Okay, Okay, so sir, we can take your system in the remote after this hands-on session, and then we will try to find out what mistakes, maybe something why mistake you have done some
Okay.
mistake. That's why some problem may be there.
Then
But
it will be good. Otherwise, we cannot explore this whatever we are supposed to do.
Mhm.
In within 3 4 days, if we are utilizing it in a better way, then we can move ahead.
Yeah, definitely. Once this hands-on session, your license is valid up to 1st January. So even that we will also able to support you.
Okay.
मरो यार इसको पॉज कर दूं मैं इसको पॉज
So thank you very much to all the participants to carefully listening this session. In second session, you can also try by hands-on session where you can open your software and how this kind of structure can be built by yourself. The hands-on session can be tried at 2 p.m. Thank you once again and have a lunch break.